How much electric force is exerted by one electron on another if the distance between the two electrons is 3.1 times 10 to the power of minus 6 meters? Okay, so to solve this problem, we have to employ Coulombs Law, which tells us that the electric force acting between any two charged objects will be K, the Coulomb constant, times Q1, the charge of one object, times Q2, the charge of the other, divided by R squared, where R is the distance between them. So we know K, it's a constant, so it should be given, or maybe you'll have it memorized. It's 9 times 10 to the power of 9 Newton meters squared per Coulomb squared. In this case, we're given the value of R, 3.1 times 10 to the power of minus 6 meters. And since we're told that both charged objects in this instance are electrons, we can determine their charge as well. So an electron or a proton will have a magnitude of charge that is equivalent to the elementary charge, which is 1.602 times 10 to the power of minus 19 coulombs. So for an electron, that charge will be negative. For a proton, that charge will be positive. Okay, so let's plug this into our formula. So the Coulomb constant, 9 times 10 to the power of 9 Newton meters squared per Coulomb squared, will be multiplied by Q1, the charge of one electron, which will be negative 1.602 times 10 to the power of minus 19 coulombs. And since Q1 and Q2 are the same, in this case I'm just going to save some writing. We're just going to write negative 1.602 times 10 to the power of minus 19 coulombs, and we'll write it squared, since we have it being multiplied twice. So Q1 and Q2 are both equal to this value, so I can just write it once and then write that it is squared. Okay, and that's divided by R squared, which is 3.1 times 10 to the power of minus 6 meters squared. Okay, so a quick check on the units here shows us we have Coulomb squared in the denominator, which will cancel with Coulomb squared in the numerator. So we have coulombs that'll be squared. Then we have meters squared in the numerator. That'll cancel with meters squared in the denominator. So these meters are being squared, leaving us with units of newtons, which makes sense since we're looking for a force. Okay, so now if you plug this all into your calculator, you should get a final answer of positive 2.4 times 10 to the power of minus 17 newtons. So notice that this is positive because we have a negative times a negative in the numerator, which will give us a positive value. And that positive value, in this case, indicates that the force acting between the two electrons is repulsive. So since their charges have the same polarity, the two electrons are repelled from one another. Okay, so this is the repulsive electric force acting between the two electrons.